Stop leaving free points on the table. Are you making the same 10 critical mistakes on the ACT math section as everyone else? Mistakes that sabotage your dream score? I'm giving you the solution. This is episode 1, featuring the top 10 mistake problems for the percent trap. We aren't just showing you the errors, we're providing the definitive solutions for every single trap. Get ready to fix your top 10 percentage weaknesses and boost your score right now. This is the mistake most students fall for. This is the most common percent trap on the ACT. A laptop originally costs $800. First, it's discounted 15%. Then, you get an additional 10% off the sale price. Most students quickly add them. 15 plus 10 equals 25% off. They calculate 800 times 0.75, getting $600. That is the trap. Discounts do not add, they stack. You must calculate them sequentially. Here's the multiplier hack. Step 1. 15% off means you keep 85% of the value. Calculate 800 times 0.85. That equals $680. Step 2. Now, apply the 10% discount to that new price. 10% off is 0.90. Calculate 680 times 0.90. That equals $612. The correct final price is $612, not $600. Remember this rule: never add sequential percents. Multiply the factors. Use the formula 1 minus D1 times 1 minus D2. Here's the math trap that fools everyone on the act. The house value went up 10%, then immediately went down 10%. Your brain screams, it's back to the original 300,000. That is the net change fallacy. The percent changes do not cancel out because the base value has shifted. Here's how you crush this. Step 1. The 2022 increase. 300,000 times 1.1 gives you $330,000. Step 2. The 2023 decrease. You take 10% off the 330,000. That value times 0.9 equals $297,000. The final value is lower. You lost more money than you gained because your loss was calculated on a bigger number. Never fall for this symmetry trick again. This is Q3, the ACT reverse discount trap. That trips up every test taker, finding the original price. The jacket is 25% off, and the final price is $180. What was the starting price? The trap answer, $225, comes from calculating 25% of the 180 and adding it back. That is called the reverse discount trap, and it is wrong. The key is setting up the equation. If 25% was taken off, that means the $180 sale price is 75% of the original cost. You must reverse the percentage by division. Take the 180 and divide it by the decimal factor, 0.75. That calculation gives you the correct original price of $240. Remember, to reverse a discount, you divide. Follow for the rest of the top 10% traps and boost your score. Time for Q4, the reverse tax trap. You paid $535 total, including a 7% tax. What was the price before tax? Do not attempt to subtract the tax. If you take 7% of the total and subtract it, you land on the trap answer $497.55. That is wrong because the tax was applied to the unknown original price. Here's the equation. 535 is 107% of the original price. So the factor is 1.07. To reverse the tax, you must divide. Take the 535 and divide it by 1.07. The incorrect way relies on simple subtraction, making you think the tax amount is fixed. The correct way uses division. By the tax factor, 1 plus the percent. That instantly gives you the original price of $500. Here's Q5, the compound growth trap. 5,000 people growing 10% and then another 10%. If you attempt to add those, 20% total growth. That gives you the trap answer 6,000. You have to remember, this is growth over growth. You must calculate sequentially. Year 1, 5,000 times 1.1 equals 5,500. Year 2, that second 10% increase attacks the new base of 5,500. 5,500 times 1.1, the final population is 6,050. The difference is 50 extra people. The incorrect way relies on simple addition. The correct way uses sequential multiplication, applying growth to the new, larger number. This is Q6, the mixed sequence trap. A $1,200 sofa gets a discount and then tax. What is the final price? Students usually make one of two mistakes. They forget the tax, or they try to calculate the tax on the original $1,200. You have to follow the strict order of operations. Here is the correct way. Step 1. Apply the discount. 15% off means we multiply by 0.85. 1,200 times 0.85 equals $1,020. Step 2. Apply the tax. The 5% tax applies to the new price of 1,020. So we multiply by 1.05. The total final cost the customer must pay is $1,071. The trap is thinking the tax applies to the initial price. The correct method ensures both factors, discount and tax, modify the price sequentially. Here is question 7, the profit margin trap. A dress costs $80 and is marked up 60%. What is the final selling price? The common mistake is finding the markup amount. 60% of 80 is 48. If you stop there, or if you choose the wrong factor, you lose the point. The key word is marked up. The final selling price is 100% of the original cost plus the 60% profit. This means the factor you must use is 1.60. You multiply the cost by the full factor, 80 times 1.60. The final selling price of the dress is $128. The incorrect way only gives you the profit amount. The correct way multiplies by 1.60, which instantly gives you the final selling price. This is Q8, the percent of the remaining trap. You start with 30 students, 60% passed, and 50% of those earned an A. How many students got the A? The biggest pitfall here is applying the 50% to the total class size of 30. That would give you the trap answer 15. This is a two-step problem. Here's the correct way. Step 1. Find the new population base. 60% of 30 is 18 students. These are the only ones eligible for an A. Step 2. Apply the 50% to the remaining 18. Half of 18 equals 9 students. The final answer is 9. The number of students who earned an A is 9. The incorrect way uses the wrong total base. The correct way requires sequential multiplication, where the result of the first calculation becomes the base for the second. Here we are at Q9, the triple sequential trap. 3 years of change, up 5%, down 10%, up 20%. What's the final value? The massive mistake here is adding them all up linearly. If you calculate a net 15% growth, you get the trap answer $1,150. The ACT knows you do this. To solve this, you must multiply the factors together. We need the factor for each year, 1.05, 0.90, and 1.20. The correct way is multiplying your initial 1,000 by all three factors, one after the other. That multiplication yields a final investment value of $1,134. The incorrect way assumes the changes are independent. The correct way knows that every single percentage change modifies the base for the next step. This is the final boss. Q10, the double reverse percent trap. The output changed twice and finished at 540 units. We need to find the original February output. The initial thought is to reverse the last step. 540 divided by 0.90 equals 600 units. That is the trap answer. You forgot the first step. The correct way is to combine the two factors first. The process was an increase of 20%, times a decrease of 10%. 1.20 times 0.90 gives you a combined factor of 1.08. Now, to reverse the entire process, you take the final output, 540, and divide it by the combined factor, 1.08. The original output in February was 500 units. The incorrect way leads to an inflated value because you only reversed the last step. The correct way uses one single division to undo the entire sequential process. Congratulations! You have mastered the top 10 ACT% traps.